what I'm going to show you today is something that this guy, Euler, discovered a long time ago. That when you compose rotations around the cardinal axes, the x, the y, and the z, what you end up with is not some kind of weird tumbling motion, but you end up with rotation around a single axis. So if I start rotating around x and then start rotating around z, what I end up with is rotation around a single axis. Here I have a cube drawn in 3 dimensions. Let me just stop it rotating a second. I have control to rotate it around its x-axis. That's the cube's x-axis, the one that goes through the center of the green and the cyan faces. You can see the cyan face now, but not the green. That's on the other side. Let me stop it. I can also rotate it about its y-axis, which passes through its red and magenta faces. You can see the magenta face on the top, the red one's hidden on the bottom there. See, it's going through the center. Let me stop that a second and rotate around the cube's z-axis. The cube's z-axis passes through the yellow and the blue faces. Through the center of them, you can see the yellow face there, the blue faces hidden on the other side. Now, what I want to demonstrate to you is that if I compose 2 of these rotations, that is, if I rotate simultaneously around the x and the y axes, for example, I don't get any kind of weird tumbling. What I get is rotation around a composite axis, an axis made up from those 2 axes. So let me start kicking off rotating around the x-axis at unit speed, and I'll simultaneously rotate around the y-axis at unit speed. Now, what this is doing is rotating about an axis that passes through the line between the red and the green faces, midway through that, and the line between the cyan and the magenta faces, halfway along that. Alright, so that's disappearing it then into the screen. If I then give it a kick along the to rotate around the z-axis, it should start rotating around 2 of the vertices of the triangle. The one at the front there, cyan, blue, and magenta, and at the top, the red, green, yellow. So here we are rotating around 2 points. You can see them at the bottom of the screen and at the very top of the screen. Put an axis between those 2 and you've got rotation around that axis. So there we've got 3 axes rotating at unit speed around x, y, and z, coming out to be a rotation around a single axis. That's kind of cool. Axial rotations, when composed, give you an axial rotation. So axial rotations are closed under composition, in our case, matrix multiplication. That's why on spacecraft the attitude jets, like these here, are at right angles to each other on the principal axes of the object. These jets are taken from the old Apollo spacecraft. The astronauts know that by applying rotations in different orthogonal directions will add up to a rotation around a single axis, not send them spiraling off in space. That's all for now. Bye!